In the last couple of videos, we talked about arrays and objects, and I mentioned how arrays and objects behave differently than other variable types such as booleans and strings because they deal with references instead of values. And in this video, I want to show you a visual example of how that works and then dive into some code to explain it further. So to get started, we have this simple visual example where we created the variable a and defined it to the value 10, and we're creating a variable b and we're defining it to the value high. And what happens when we do that in JavaScript is that we have this table down here which defines our variables based on their name and then the actual hard value of that variable. And in our case, this is fairly straightforward. We have the variable a with a value of 10 and the variable b with the value of high. I mean, that's exactly what we would expect to happen in this type of scenario. So now let's go a little bit further. Let's create c and set it equal to a. How exactly does this type of scenario work? I mean, we know based on doing this before that c is going to have the value of 10, but how does that work? Well, what happens is we look down in this table down here and we say, okay, the variable a is defined here and it has a value of 10. And we take the value of a and we set that as the value for c. That's what happens when you define one variable equal to another variable. So we're taking the value of a, which is 10, and we're plopping that in here as the value of c. That's pretty straightforward. Now let's say that we want to take c, we want to add 1 to it, and then we want to set that back to our value of c. What happens to our variables a and c? Well, most likely you've done something like this before, and you know that a is going to be 10, and c is going to have the value of 11. Because all we're doing is we're taking c, we're looking at the value which is 10, or it used to be 10, then we're going to add 1 to it, which gives us 11, and then we're setting that to the value of c, which in our case is right down here. So c is 11, and a is not touched at all. This is because we have a hard value here. We're not referencing anything, we have an exact value. This value is 10, this value is 11, and even though c is equal to a at this point, we set c based on a, c has no idea about a. It doesn't know a exists, it just knows, hey, my value is 10, a hard-coded value of a number, or a string, or a boolean. All of those act exactly the same. So now how does references work? If we move forward here and instead we set c equal to an array, with the value 1 and 2, what is the value of c going to be? Well, you would think this value would just be an array of 1, 2, but that's not quite how JavaScript works. Instead, when we have an array or an object, they both work exactly the same. What we do is we actually allocate some memory, and then the address of that memory on our computer, so the location of that memory on our computer, is what we set as the value here. So let's take a look at how that works. So we have c here with the variable, and we have this value here, which is this weird bracket notation 0x01. All this 0x01 means is this is a location. This is just an identifier of a location. Imagine you had a hotel and you said room 3. This would be like room 3 is where c is at. And as you can see, that address over here equates to a specific value. And this address is somewhere in the memory of your computer. So inside the memory of your computer at this location, for example, your memory would be like the hotel in this example, and this address would be like room 3. You have the value of 1, 2. This would be like the people staying in that hotel room. So in our case, we have this value at this memory location, and c is set to that specific value. Now let's go a step further. Let's take d and set it equal to c. If you remember in the previous example when we set a to c, what we did is we went to a, looked at the value right here, and we set that value to c. Now when we're setting d equal to c, we look at the variable c, look at its value, which is 0x01. This is that room number essentially in the hotel example, and we set that as d. So as you can see here, d has the value of 0x01. They have the exact same value, and these values reference a place in memory. They reference the exact same location. So both d and c are referencing the exact same array. So now, when we add an element to d by saying d.push3, this is adding 3 to the end of the array, you notice it changes over here. We have 1, 2, 3 now, but it changes for both c and d because they both reference the exact same memory address. This idea of a reference to a location is what's called references. So we have value where you store the actual value, for example, 10 or high for an array. And then there's references, which is what you do when you deal with objects or when you deal with arrays. And it stores a reference to a location in memory. And that location in memory is where the actual value of the array or object is stored. So when you set c equal to d or d equal to c, you're just sharing this same reference to the exact same value. What happens if instead, though, we set d equal to its own array down here, 3, 4, 5? Well, since 3, 4, 5 doesn't actually exist yet inside of our address over here, it's just a brand new array, what we do is we create a new location in memory. This would be like room 4 in our hotel. and we give it this value 345. And now D is referencing that OX02, essentially, room 4. So C is referencing one place, D is referencing another place, and now when we modify C or D, it's not going to affect the other one. Now there's a lot of hypotheticals in this example on what exactly does what, so I want to jump into the code and show you exactly how this works so that you can really play around with it and understand yourself, because this is a super important concept to understand. So now that we're back in our code, I kind of want to just run through the examples we talked about a little bit. So we had let A equal 10, we're going to say let B equal high, and let's just console.log. We're going to say A equals, and we're going to put A in here, and we're going to do the exact same thing for B and set that equal to B. This is just a nice little handy string notation we can use to see what each of our strings is. So A equals 10 and B equals high, just like we expect. Then we can say that C is going to be equal to A. If I just copy this down and say C and C here, we can see that C has the value of 10. And if I set C equal to C plus 1, you can see that C changes to 11, but A stays the same, just like we would expect. Now, if we do the array version here, though, we have C, which is the array 1, 2. And you can see I get 1, 2 being printed out. That's just this array converted to a string. And then if we come in here, we can say D is equal to C. And I log out what D is over here. You can see they both have an array of 1, 2. And then if I wanted to come up here and say D.push3, what this is going to do is it's going to modify the array that both C and D are referencing. So now C and D have 1, 2, 3 inside of the array. And this is the thing a lot of people get tricked up on. Because if you think about it, when we create a new array like this with this bracket notation, we're creating a memory address. So in our case, our memory is OX01. Let's just pretend this is where it is. This is room number 3 in our hotel. And now when we set D equal to C, we're just getting that OX01. And now D is also pointing to OX01. They both point to the exact same location. So when we modify D, we're modifying this location, and both of these point to that location. If we were to go even a step further and instead just change D to its own array, 3, 4, 5, then we're going to add 6 to the end of the array, you can see that C doesn't get changed because when we create a new array like this, we have new memory. So we'll say OX02 is our new memory address. So as you can see here, C and D are both different memory addresses. And this is really important to understand. This works with arrays and with objects. So if we had an object, for example, that was like name Kyle, and that's at OX01, and we set D equal to C, and we just did here, D dot name equals Joe, and we save. Now let's just convert these to a string. So we can just say JSON.stringify. This is going to convert our object to string notation, which is easy to read. Let's just do this for both of these. Whoops, not for A and B. We're going to do this for D and C. So we can say JSON.stringify and JSON.stringify. Now it'll actually print out our object, and you can see both of them have the name of Joe. And the reason for this is, again, these are both set to the same memory address because we're not creating a new object, we're just referencing the object we've already created inside of C. And just to talk about this JSON.stringify a little bit more, JSON is just an object called JSON, and it has a function on that object, a property called stringify, where we just pass it an object, and it'll convert that object into a string version, which we can print to our screen. So that's what JSON stringify is for, really useful for printing out objects. Now, if this wasn't already confusing enough, I have another thing that's going to confuse you even further. Let's come up here and create a variable called A. We're going to set it to an array 1, 2. And we're going to create another variable B. We're going to set it to an array 1, 2. And then I just want to console.log A equals B. What do you think this will return? Do you think it's going to return true? Do you think it's going to return false? I mean, they're both the same elements in the array, so that should return true, right? Wrong. It actually returns false. And the reason for that is because when we compare two elements inside of JavaScript with the equal syntax, whether it's 3 equals or 2 equals, both exactly the same, what you're doing is you're comparing the value of these elements. And if you remember from the diagram earlier, these elements, A and B, they have a value which is a memory address. So in our case, OX01. And this, since it's a brand new array that we're creating, it has a new memory address, OX02. So what we're saying is OX01 the same as OX02? Obviously not. I mean, those are completely different numbers. That'd be like saying that you have a person named Kyle in hotel room 3, and you have another person named Kyle in hotel room 4. Clearly, they are not the same. They're not in the same place. They're not the same people. They're completely different entities. So they wouldn't be equal to each other just because they both have someone named Kyle inside of them. They're completely different places. And just like that, these two arrays are completely different. You can even see that because if we do A.push3 and we just log out A here, and we log out B here, you'll see that A has 1, 2, 3, while B only has 1, 2. So they reference different places. So we can modify A without modifying B, even though they both start out with the exact same values inside of them. Really, the important thing to think about with this whole reference versus value is think about what we're setting the actual value of A to. Don't think about what is on the right side of this equal sign. Think about the value. In our case, this value is a memory address. So when we do comparisons, we're comparing these memory addresses to one another. And when we're dealing with const and let, what we're doing is we're making sure we never change this memory address. So let's change both of these to constant variables. And remember, I said const means you cannot change the variable. But what that really means is you cannot change the value, in our case, OX1 and OX02. But we can actually change the place in memory where this variable is. We can change what that memory value holds. In our case, we have const A, and we're adding 3 to A. You would think immediately this would throw an error. But if we just save, you'll notice no errors get thrown. And that's because A still has the memory address OX01. That is like the hard-rooted value of this variable. That never changed. All we did is just change what's at that memory address. But const doesn't care about that. Const only cares if you change the memory address. And the only time you can change the memory address of an object, or an array in this case, is if you redefine it with the equal sign. So if we redefined A to be 1, 2, 3 like this is defining a new place in memory called OX03, for example, and now this is going to throw an error. As you can see here, we have an error. If we go over to our console, it says assignment to constant variable. So the only time that we have to worry about changes to constant variables is when we redefine them, but we can modify them as much as we want. For example, we could do the push here to add an element to it. If we had an object, for example here, name of Kyle, and here that has that value of OX01, and we just said a.age is equal to 25. We're adding a new property of age to this object. And let's print this out down here. You can see we get Kyle and age. And even though we changed this object, we even added a whole brand new property to it, we never redefined where it's stored. It's still OX01. If we were to do this though, we said name is Kyle and age is 25, now we're creating a new location in memory, OX02. And now this A is going to give us an error, as you can see here, because we are essentially trying to redefine this constant variable's location. But the main thing you really need to think about with all this, all of these weird edge cases that seem out of place, they all are because arrays and objects are references. And all that they are storing is this reference. And this reference is where this data is stored. But you don't care about that. All you care is that it has a reference as its value. So this reference is what you're comparing. This reference is what you're determining whether or not you're changing with const. This reference does absolutely everything, even if we have a function. For example, let's just say const A is equal to an array. We'll call it 1, 2. And we're going to create a function down here, which is called add. And this is going to take an array, and it's going to take an element. And all it's going to do is just say array.push element. So we're going to add an element to this array. And then what I want to do is I want to call that function. So we'll say const element to add is equal to 3. And then we're going to say that add A, and we're going to put in our element to add. So we're taking our array A, we're adding the element here, which is 3. So we should have 1, 2, 3 being printed out. Come down here, we can say console log A, and we get 1, 2, 3. But why exactly does that work? If you remember correctly, function is like its own scope, while this other section out here is its own scope separate from that. So when we make changes to things inside of a scope, how does it persist out here? Because how does A, which we pass in and it gets redefined as this array variable, how can we actually modify that? Because if we take element and we say element equals element plus 1, we're redefining element to be element plus 1 and then adding it to the array. And now it's console.log out our element to add. You'll see that our element to add is still 3, even though we redefined it to be a new value of 4, because 3 plus 1 is 4, it didn't actually change our outside element to add here. Why exactly is that? And it's all because of pass by reference. This A here has a value, which is OX01, for example, while element to add just has a value of 3. It's just the hard-coded number itself. So what we're doing when we come down to our add function, and we call it with this line here, is we're passing in our array, which is this value of OX01, and we're passing our element to add, which is just the number 3. So inside of here, we have OX01, and we have 3. So this element is just a value. It doesn't reference this outside element here. They have no connection. We just have a copy of this value here, 3, being passed along, and this new value for element is just, being set to 4 because it's just a new element, it's a new value. It doesn't matter. It doesn't have any reference to element to add. But this array down here, this array still references 0x01, which is our array up here. So when we modify our array in here, we're actually modifying our outside array because we're changing the value in the memory address 0x01, and we're not actually changing the value of itself. This is essentially the same as if we were to do, const array equals a. That's all that calling a function does, is it's setting this array value equal to whatever we pass in, a. So we're just doing this essentially. And we already know that this is going to be causing changes, because if we did down here, a array.push, and we were to push just 4 in there, for example, we already know that this is going to modify both a and array because they both reference the same place, this 0x01. It works the same way with functions. We're passing in that 0x01 reference, and we're modifying it so it's going to update everything that references 0x01. Now this is a lot to take in. I admit there is a ton in this single video because reference and value, it's a pretty confusing topic, but the main takeaway is when dealing with arrays and dealing with objects, they are references. So whenever you modify an array or modify an object, you're modifying that reference. And whenever you set something equal to a currently existing, object or array, you're using that reference. So they share the same reference. While numbers, strings, booleans, those are just values. They never have a reference to anything, so it's always just an individual value. They can never reference other numbers or other strings, for example. And in order to wrap your head around this, I just recommend trying out different things. See what happens. Create an object, try to set it to another object, change some values, just see what happens, and that'll help you really understand how this works. And as we create more projects and exercises in this course, it'll really drill in this idea. Now in the next video, we're going to dive away from some of this harder stuff and go into a much easier concept, which is methods on the array. So essentially functions on the array that we can use in order to do a bunch of different things with arrays. I can't wait to see you in that video.